Welcome to Math 155, section 8.4, integrated review. In this lecture video, let's take a look at what we so-call the Cartesian coordinate system. So basically the rectangular coordinate system, or what we so-call the Cartesian coordinate system, was actually developed by René Descartes for solving geometric type of problems using algebra. Okay, so the x and y axis was developed by René Descartes. So Descartes based his x and y axis, this system, on a relationship between points in a plane and ordered pairs of real number. So as you can recall, learning about the x and y axis, okay, so the points, okay, or the ordered pairs, is always come with the x value first and the y value next. So this is called the points or coordinates, or sometimes we call them ordered pairs. So where the x and y axis meet is called the origin. So to the right and above the origin, that's called the first quadrant, where both the x value and the y value is also always positive. Second quadrant to the left, where we got negative for x value, positive for the y value. Third quadrant is to the left and below the origin. Both x and y value are negative. And the fourth quadrant, okay, to the right and below the origin, where we get positive x and the negative y value. So the quadrants for right now kind of help us where our points is going to be located. So for example, if I have a point that is negative 2, 3, the first value is always an x, is referring to the x value that tell me to go right or left from the origin. And then the second number, which is the y value, tell me to whether go up or down after I moved on the x direction. So if I have a point here, let me create a little point. When we plotting points, okay, we always start from the origin. So negative 2, 3, negative 2 means go to the left 2 first, and then the 3 means go up 3 units, okay? So this particular order pair, this particular point, coordinates, okay, is actually going to be right here in the second quadrant. All right, so remember now, this is only one point, okay? A lot of students end up go to the left 2, put a point there, and then go up 3, put another point there, okay? And that will actually be incorrect. This is only one single point, so the x value tell me to go right and left based on negative or positive. And then once I go right or left, the second number, the y value, tell me to go up or down based on positive or negative. So one of the very first thing I want all of us be able to do is be able to plot these points. So plotting points on the computer for your homework is very different. So basically you can just click on them, okay? Click on the appropriate points, all right? And then once you plot all 3 points just by clicking on them on the homework, then you can actually submit for the answer. All right, so let's try these 3 points real quick. So 1, 6, whenever I plot a point, I always starting from the origin. 1, 6 tell me to go to the right one and up 6 units, so that will be right here. This is my point A. Point B, negative 5, negative 6. So the first number tell me to go to the x direction, which is left and right. So go to the left 5. And the second number, negative 6, tell me to go down 6. So that will be about right here. All right, so that's in the third quadrant. Now point C is negative 2, negative 3. So that will be go to the left 2 and down 3. 1, 2, 3, that will be right here. All right, so now this is basically plotting the 3 points. So now step number 2 out of 2 here want us to give us 3 points plotted. Now we just need to write down the coordinates for those 3 points. So your very first point A, to get there, starting from the origin, we will need to go to the left 6 places, then go down 4 to reach point A. So that will be Go to the left 6, that will be -6, comma, got to type in comma, and then go down 4. So the y value is -4. All right. So start a parenthesis on the so start out with a parenthesis, and or sometimes they just want us to key in these 2 points. Okay. So in a different video, I will show you. I will tell you there are 2 ways that we can actually do this. Okay. To actually draw a line. Either we will write out the equation, or we can just enter the points on the homework. All right, point B. To reach point B from the origin, we've got to go to the right 1, 2, 3, and down 2. So right 3, then down 2. So the y value is -2. All right, point C. Very important. Starting from the origin, if I only go to the left 3, then my x value is -3. But since I don't need to go up or down, all right, so then my y value will be 0. So let me add a point D. And I'm going to purposely put my point D right here. So if I want to reach point D, to get to D, I do not need to go to the right or left. So that means my x value got to be 0. All right, so simply go straight up 3 to reach my D. So the y value will just be 3. So C and D, okay, are 2 very important coordinates by them located on either the x-axis or the y-axis. So on the x-axis, this is very important. On the x-axis, any points located on the x-axis, I will simply go to the right so many places or go to the left so many places. So that means my x value is changing, but my y value, remember now the origin is always 0, 0. So if I simply go to the right or left, my x value is changing, but my y value actually stays as 0. So any coordinate on the x-axis, all the y values are actually 0. All right, so if I want to plot any points on the y-axis, then I do not need to go to the right or left. I simply shift, okay, up or down. So that means on the y-axis, okay, all the x values, okay, are actually 0. All right, very important concept. So if you simply go up 1, that will be 0, 1. If you go up 2, that will be 0, 2. Go up 3, that will be 0, 3. If you go down 1, that will be 0, -1. Go down 2, will be 0, -2. Go down 3 will be 0, -3. So the x value remains as 0 on the y-axis. It's only the y value changing. So on the x-axis, if you only go to the right so many, go to the left so many, then the x values are changing, but the y value remains as 0. All right. So keep that in mind for other lecture video where we will actually need these 2 concepts. All right. So let me introduce this thing real quick. Something called the equation of the line. I use this phrase a lot. So ultimately, in this particular test material, this is our test number 5, we want to be able to plot points in order to draw a line. And once we draw this line, this is called the equation of the line. Equation of the line simply means every equation, every linear equation, okay, has a line or is a line, and every line you see is an equation. So here I'm given an equation of the line called 3x minus 2y equal to 8. And what I want to do here is to determine if the given point 2, 5 satisfy the equation. So what that means is when I plug in 2 for x, if I plug in 2 for x, 5 for y, will this satisfy the equation? That means will the left side equal to the right side? So all we're going to do is substitute 2 for x, 5 for y, and then trying to see what this is going to turn out to be. So 3x means 3 times x. Now will be 3 times 2. I'm substituting 2 for x. minus 2 times y. Now I'm replacing y with 5. Does that equal to 8? All right, so this is going to be 6 minus 10, which does not equal to 8 because this is going to be negative 4. All right, so my answer here is no. It does not satisfy the equation. Okay, so what does it mean? So what it really, let me write it down, okay? So no, I'm going to write a little bit more. No here simply means 2 comma 5 does not satisfy the given equation of the line. Now, what is also saying here, remember now, right now I'm using the word equation. So every equation of the line means the equation is the line is the equation. So if this particular coordinate does not satisfy the equation, that simply also implies that 2 comma 5 is actually not on the line. Okay, that's what that means. That particular point is actually not part of the line that we are going to learn how to draw. All right, let's try this one. Okay, does this point satisfy the equation, or is this point on the line? So this time I'm going to substitute negative 1 for x and 5 for y. So that will be 3 times x. Now it will be 3 times negative 1 minus 2 times 5. Does that equal to 8? So this is negative 3 minus 10, which we know turn with the same sign. We add, so this is negative 13, which does not equal to 8. So the answer is no again. Okay, so that means this point does not satisfy the equation, and this point is actually not going to be on the line. All right, so the following few exercise is basically a way trying to show us how do I actually find, okay, the point that is going to be on the line. So basically what we are going to do, okay, the overall idea here is be able to find points, okay, from the equation of the line in order for us to draw the line. So this particular example give me, okay, it tells me it wants negative 2 for x. So my job will actually find the y value. So once I'm able to use the equation of the line to find the y value, then I will actually have a point that is going to be on this line. Excuse me. It makes sense because we are using the equation of the line in order to find the points that we need to draw this line. All right, so basically all I'm going to do is substitute negative 2 for x so I can actually solve for the y. So this is going to be 2 times normally x. Now you will times by negative 2 minus y equal to 3. So let's simplify this. This is going to be negative 4 minus y equal to 3. So solving for y. So as you can see, my variable y is negative. So what I can do as far as solving linear equation, I can move my y to the other side. I can move my variable term to the other side. It will instantly become positive y. So at the same time, I'm going to move my positive 3 back over to the left side. So on the left side, negative 4 still negative 4. When positive 3 come over to the left side, become negative. So let's combine negative 4 minus 3. If you put that in your calculator, my y is equal to negative 7. So that means now this question mark here is now negative 7. So this particular point, negative 2 for x, y is negative 7, will satisfy the equation of the line. Therefore, that means this point will be on the line. Now, why do I do this again for stat number 2? Because if you think about it, though, a line that we are going to draw in the next video has infinite number of points. But just to draw a line, I would need at least 2 points. Okay, I need 2 points to draw a line. But once I drew that line technically has infinite number of points on there. So this time it tells me that the y value is -1. It given me y value is -1. So our job is to find the x value. So I'm going to replace, this is where we got to be careful, replace -1 for the y. So that will be 2x minus, all right, substitute y for -1. So this term, this second term is really a -1 times -1, which will actually becomes +1. So my 2x plus 1 is now equal to 3. So our job here is to solve for x. So since my variable term is positive already, I'm going to let it stay. So let's move the +1 over. So that will give me 2x equal to 3, still 3. +1 come over, become negative. So I should get 2x equal to 2, and x is equal to 1. Divide both sides by the coefficient, like we did back in test 1. All right, so it come find out when the y value is -1, the x value is 1. So now, once I got 2 points, I can connect them with the line. And that's how we actually find, that's how we actually going to find the equation of the line. All right, so let's try some other similar exercise here. So this one, you draw out the x and y table for me. So same thing, we're going to substitute 2 for x, so I can find the y value. So that will be 1 point. And now I'm going to substitute -3 for y, and then so I can solve for x, so I can get another point. And then I'm going to plot the 2 points as a step number 2, okay? All right, so let's try this, okay? So when x is equal to 2, so substitute 2 for x so we can solve for y. That will be 6 normally times x, now we'll times 2, plus 3y equal to 9. So this is going to be 12 plus 3y equal to 9. All right, solving for y, so my variable term here is positive. Since it's positive, I'm going to let it stay here on the left side. So move my 12 over. So that gives me 3y is 3y equal to 9, still 9. Positive 2 will come over, become negative. So this is going to be 3y equal to -3. Divide both sides by 3, so my y value will be -1. So when x equal to 2, my y value is -1. All right, let's do this one. When y is -3, all right, substitute -3 for y so we can solve for x. So that will be 6x plus 3 times -3 equal to 9. All right, solving for x. So this is going to be 6x positive 3 times -3 is -9 equal to 9. So since I'm solving for x and my variable term is positive, so I'm going to let it stay. So move my -9 over to the other side. When I do that, ooh, Lord, I'm trying to it's all right. So 6x is 6x equal to, this 9 is already here on the right, so still there. When -9 come over, it become +9. So that will be 6x equal to 18. Divide both sides by the coefficient 6, my answer x equal to 3. So when y is -3, my x value will be +3. All right. So now this 2 comma -1 is 1 point. So let's plot that point. All right, 2 comma -1. And my second point is 3 comma -3. So 2 comma -1. So to plot this point, I will need to go to the right 2 and down 1. So that's my first point. My second point, 3 comma -3, starting from the origin, go to the right 3 and down 3. 1, 2, 3. So that'll be right there. So these are my 2 points. Okay, just plotting them. All right. Now let's try this one. Okay, this, consider the equation v equal to 6 times h. So rather than call the X and Y, right now we call them V and H. So the H in the first column representing the X value, the V representing the Y value. Okay, so V also stands for volume, okay, of a box with a variable height of H in centimeters, okay, and a fixed base of an area of 6. So complete the table below. So all I'm gonna do is basically substitute 2, 5, 8, and 10 for H so I can see the volume. So my volume equal to 6 times 2, which we know is 12. All right, next point, 6 times 5, which is 10. All right. No, 30. I'm sorry. I don't know what I was thinking. All right, the next one, 6 times 8, 48. And the last one, 6 times 10, which is 60. All right, so I complete my table. So each one of these, H and V, representing a point. Okay, representing a point. So when we learn how to graph the equation of the line, okay, we will create our own, okay, X and Y table. So plot the points corresponding to the order pair from the previous part. All right. So the homework already scaled this for me. All right. So the y-axis representing V, x-axis representing H. My first point, 2, 12. So if you look at the scale, the x-axis scale is 1 at a time. The y-axis scale is actually jump up 6 at a time to help us to plot these points. So the first one was, what was that? 2, 12. So from the origin right here, go to the right 2, go up to 12. And the next one was 5, 30. Go to the right 5 and go up to, it says 30 across. Very good. 8.48. Go to the right 8 and go up to 48. Oops. And the last one is 10 for X. Y value is 60. All right, go to the right 10 and then we go up to 60. There you go. So these are the 3 points. So once I connect them with the line, okay, this is actually a straight line, which is called the equation of the line. Learning how to draw a straight line. Alrighty. So just a quick lesson on how to find coordinates using the equation of the line. So next lecture video, I will actually begin to draw the line, to actually use the equation of the line to actually find 2 points so we can actually connect them with the line. All right, that will conclude this lecture video. Thank you for watching.